All right. Guys, you are welcome once again to Divine Brain TV. In our first video, we talked about introduction of vectors in a plane figure. Yes, in a plane. Yes, in elective mathematics. So today too, we are going to continue. We are going to continue the introduction that we did. And today, this is what we are going to treat. We are going to look at the magnitude of a vector, equality of vectors, addition of vectors, and then multiplication of vector by a scalar. So this is what we are going to talk about. And please remind you, if today is your first time of watching one of our videos, just please subscribe and hit the notification so that you're able to get all the updates of our video. All right. So please, let's start. Let's talk about first magnitude of a vector. And when we say magnitude of a vector, when it asks you to find the magnitude of a vector, we have a formula or special way of doing the magnitude of a vector. And I've already explained what magnitude is in our previous video. So make sure you can just go and make reference and understand the meaning of magnitude. Here we are going to learn how we can calculate for our magnitude if a vector, one or more vector is given to us. Let's look at how we are going to look at this magnitude. All right. So now we say that magnitude of a vector. And ask us to find the magnitude of a vector. It's very simple. Assuming we have our vector BC, 2, 3. And then we ask her to find the magnitude of this. So in finding the magnitude of this is how the formula goes. The formula goes like, when I have vector BC, and I have x and y components, and then I've been asked to find the magnitude of this vector BC. This is how you denote vector BC. You just bring two vertical lines and then the vector BC be in the middle. So in finding the magnitude, we have our square root, and then we bring this x component to that, we square it plus this y component. This gives us the formula for magnitude of vector. That is the general formula. Good. And in other words, when we give you maybe a vector A is equal to xi plus yj, and ask you to find the magnitude, please, it's the same procedure. It's very simple. So the magnitude becomes square root of x squared plus the y squared. And mind you, this x and y represent the values in which will be given to you. For example, in vector BC, our x is 2, our y is 3. Likewise, in this vector A, our x here is 2, our y here is 3. Simple like ABC. So these are the vectors. So in this question, we have been told to find the magnitude of vector BC. It's very simple. So this is how we go by using the formula. BC will give us, don't forget how you denote magnitude. It's equal to square root of, we know that our s component will become s equal to y. Then we use the same formula. We bring our square root, then we square this, because we have square over here. So we need to square 2 and bring it to the here. Good. And then plus this 3 squared. Then we solve this. So this will give us 4. This will give us 9. And then we add. We get 13. So you can decide to change this to a decimal, or you can decide to remain like this. So this becomes root 13 units. So this is how we find our magnitude. Any kind of question, any kind of vector that we ask you to find the magnitude, It is the same approach, nothing different. So make sure you take note. So in case one of these components is negative, make sure you put the negative of that number in brackets before you bring your minus. Make sure you do that. If you don't put it in brackets and you square it, please you get it wrong. So make sure you do that. Quickly, let's move to our next point, equality of vectors. Equality of vectors. So when we say equality of vectors, assuming two vectors has been given to us. For example, assuming we have vector DC, let me say DE, sorry, DE to be equal to 5 net 2, like this. And then they have given us another vector, let's say EF is equal to minus 1, 1. And we ask us to find equality between these two vectors. These two vectors. It's very simple. When you say equality of these two vectors, it means that DE, vector DE, is equal to EF. Very simple. So this means that when we have 5 over here, minus 2 is equal to minus 1, 1. That's how the equality of vector tells us. This means this vector is equal to that vector. So this means that assuming we have our position vector A and the position vector B, and we say that the equality of vector between position vector A and B means that A is equal to B. That is equality of vector. So let's look at how we are going to solve an example with this. Very simple. So let me wipe my board and then we are going to, as we're doing the equality of vectors, it's very simple, not anything difficult. Make sure you bring your attention over here. Simple. So let's continue. So we're assuming we say that if A and B, if A is equal to B, and we have our first vector to be x1, y1 to be this. Then we have B to be x2, y2. That's the vector. And then we say that vector A is equal to vector B. This means that x1, y1 is equal to x2, y2. Therefore, this x1 is equal to y2 over here, sorry, x2, and then this y1 is equal to y2 over here. So this is the whole of equality of vectors. So let's solve one example and then let's run. Alright, so let's take this example. Say that if P is equal to x plus 3, y, say y plus 1, and Q, vector Q is equal to minus 3, say minus 2, then 3. Then we ask us to find x and y if P is equal to Q. So this is the question. This is the whole of the question. Vector P is equal to x plus 3, y plus 1, and Q is equal to minus 2, 3. It asks us to find x and y, that's the value of x and y over here, if P is equal to Q. This is a typical example of equation. So let's do solution. Alright, so we know that if P is equal to Q, then P of this is equal to that. So we will equate the vector of the P here to the vector of the Q. Very simple. So this is how it goes. X plus 3, y plus 1 is equal to minus 2 3. So if P is equal to Q, then it's this. Very simple. Alright. So then you just equate each of the corresponding component. For example, this is our x component, this is our y component, this is the x component, this is the y component. Therefore, we will write this and equate to its corresponding component of the other vector like this. X plus 3 is equal to minus 2. Equation 1. Then we come to this side. Y plus 1 is equal to 3. Equation 2. Please, don't equate this to the component. Make sure when you pick x components from the first vector, you are going to equate it to the x component of the another vector. Don't interchange them. Other than that, you get it wrong. So please, let's first solve equation 1. So equation 1 says x plus 3 is equal to minus 2. So how does it go? X plus 3 is equal to minus 2. This means that we can make x as our subject because we are finding our x. Other than that, you can find the negative of this number, then you add it to this side, add it to the other side, so that this one becomes 0. To left is only x over there. Any way that you choose to do it is acceptable. All what you need to do is to make this one to stand on its own and get the correct figure over there. So that becomes x is equal to minus 2. Taking this to minus 3. So therefore, our x is equal to minus 5. So that is our x for this vector. And then the y, also we have y plus 1 is equal to 3. Y is equal to 3 minus 1, and y is equal to 2. So that is our equality of vector. So it's very simple. So make sure you try and do something. Alright, so let's come to the next one, addition of vectors. Addition of vectors is also simple. Addition of vectors is also simple. It's like you have two vectors and you try to add them. It's very simple. So it means that we have vector A is equal to x1, y1, and vector B is equal to x2, y2. And actually to add vector A to B, that's A plus B, it's going to be x1, y1 plus, there's that, and bring the vector x2, y2. And then this become, you add this and that, x1 plus x2, y1 plus y2. So when finished, let's get your final answer. So that is addition of vector. It's very simple. This one is you just add the two vectors that they will give to you. It's very simple. So let's quickly move to multiplication of a vector by scalar. Multiplication of a vector by scalar. Okay, so assuming k is our scalar, and then we ask us to multiply this k to vector a, which is equal to x, y. It's very simple. That is going to be k times a, which is equal to k a. That is the vector. So this time we are multiplying this scalar to the a vector, vector a. And this is how it goes. So assume that ka is equal to, we bring our k here, vector. So you multiply this scalar to the x component. You multiply the same scalar to the y component, like this. This becomes the equation of example. So if vector D is equal to position vector D is equal to, let's say, 2 minus 1, find 2D. Find 2D. It means that we have multiplied the vector, this vector by 2. So then this one too is how we go about it. You write a solution. Good. So we just multiply this 2 like this. This is going to be. So we just multiply 2 by 2, get our 4. 2 by minus 1, get minus 2. This is that. So guys, it's very simple. So this is all about that. Everything is very simple. We thank you for watching our video and joining us. Please look for the next video. We are going to do resultants of vectors. So make sure you follow, you subscribe, then you like the video. Please don't forget to like the video, and see you in our next video. Bye bye.